In example 2, we're told that the total cost in dollars of manufacturing X auto body frames is given by this cost function. So the first thing we want to do is find the average cost function, which again is just taking our cost function, which in this case is 50,000, plus 300x, and dividing that by x. So that gives us our average cost function, which we can then evaluate at a value of x equals 50. So making sure we put parentheses around everything in the numerator. And we're dividing by x, which is again 50. And I put an extra slash at the end, but it looks like Wolfram Alpha ignored that. So we get 1/50 times 50,000 plus 300 times 50 gives us a value of 1,300. So interpreting that tells us that if 50 frames are produced, since that's our value for x, then the average cost is $1,300 per frame. The next thing we want to do is find the marginal average cost function. So this would be the derivative of 50,000 plus 300x divided by x, which will give us a result of negative 50,000 over x squared. So our marginal average cost function is negative 50,000 over x squared. Now we want to find that function evaluated at x equals 50 and interpret that result. So we want to evaluate that function for x equals 50. And in this case, we see that we get a result of negative 20. So our result in this case is negative 20. So what this is telling us is that when 50 frames are being produced, the average cost per frame is, in this case, decreasing, since that rate of change is negative. Average cost per frame is decreasing at a rate of $20 per frame. So as we increase production, average cost to produce each frame is actually decreasing. And now we want to use those results from part B and D to estimate the average cost per frame if 51 frames are being produced. So to come up with that estimate, we can evaluate or take the value that we already came up with, our average cost function evaluated at 50, plus our marginal average cost function, also evaluated at 50, and we can add those two results together. So this would give us 1,300, and in this case, since it's negative, minus 20. So if production is increased to 51 frames, the estimate of the average cost per frame is going to be that 1,300 minus 20, or $1,280. So again, this marginal analysis is basically the idea of taking the derivative of whatever function we're considering, combining that with what we already know about the function value to get an approximate or an estimate for that cost, revenue, profit of increasing production by 1.